Welcome to this lesson on permutations in mathematics. Permutations are a fundamental concept in combinatorics and have many applications in various fields of mathematics, computer science, and everyday life. So, what exactly is a permutation? A permutation is a specific arrangement of a group of objects in a particular order. In other words, it's a rearrangement or reordering of objects where the order matters. Let's illustrate this concept with a simple example. Suppose we have three different fruits, an apple, a banana, and an orange. We want to know how many different ways we can arrange these three fruits in a row. To find all possible permutations of these three fruits, we need to consider the number of options we have for each position. For the first position, we can choose any of the three fruits, so we have three choices. For the second position, we've already used one fruit, so we have two choices left. And for the third position, we only have one choice left, which is the remaining fruit. Using the multiplication principle, the total number of permutations is 3 times 2 times 1, which equals 6. Now, let's list all possible permutations of our three fruits. Apple, banana, orange. Apple, orange, banana. Banana, apple, orange. Banana, orange, apple. Orange, apple, banana. And finally, orange, banana, apple. So we have 6 different ways to arrange our three fruits, which confirms our calculation. This example illustrates a general formula for calculating permutations. For n distinct objects, the number of permutations is n factorial, which is written as n. N factorial is the product of all positive integers less than or equal to n. For example, 3 factorial equals 3 times 2 times 1, which is 6, as we saw in our fruit example. Now, let's consider a more general case, where we need to arrange only some of the objects from a larger set. This is called an R permutation, or a partial permutation, where R is the number of objects we're selecting and arranging from a set of n objects. For example, suppose we have 5 books, but we only want to place 3 of them on a shelf. How many different ways can we arrange 3 books out of 5? For the first book, we have 5 choices. For the second book, we have 4 choices remaining. And for the third book, we have 3 choices. So the total number of ways to arrange 3 books selected from 5 is 5 times 4 times 3, which equals 60. The formula for R permutations is written as P of n, or sometimes as P sub n, R. It's equal to n factorial divided by open parenthesis n minus our close parenthesis factorial. We can also write this as n times n minus 1 times n minus 2, and so on, continuing for our terms. Let's apply this formula to our book example. We have n equals 5, and R equals 3. So the number of permutations is 5 factorial divided by 5 minus 3 factorial. That's 5 factorial divided by 2 factorial, which is 5 times 4 times 3 times 2 times 1 divided by 2 times 1. The 2 factorial cancels, giving us 5 times 4 times 3, which equals 60, confirming our earlier calculation. Let's look at some real-world applications of permutations. One common application is in creating passwords. Let's say you have a 4-digit PIN code for your bank card, where each digit can be 0 through 9, and digits can be repeated. This is actually a permutation with repetition, and the number of possible pins is 10 to the power of 4 or 10,000 different codes. Another application is in license plate numbering systems. For example, if a license plate consists of 3 letters followed by 3 digits with no repetitions in either the letters or digits, we would calculate this as 26 times 25 times 24 for the letters, multiplied by 10 times 9 times 8 for the digits. This gives us over 11 million possible license plates. In competitions like a race with 8 participants, permutations determine the number of possible orders for the top 3 finishers. Using our formula for R permutations, that's P of 8, 3, which equals 8 factorial divided by 8 minus 3 factorial, which is 8 factorial divided by 5 factorial. This gives us 8 times 7 times 6, which equals 336 possible podium arrangements. To summarize, permutations are arrangements of objects where the order matters. The formula for the number of ways to arrange all n distinct objects is n factorial. The formula for the number of ways to arrange our objects selected from n distinct objects is n factorial divided by open parenthesis n minus our close parenthesis factorial. Permutations have numerous applications in combinatorics, probability, computer science, cryptography, and many aspects of everyday life. I hope this video has helped you understand permutations in mathematics. With this knowledge, you'll be able to solve a wide range of counting problems where the order of selection matters. Thank you for watching.